of all, distribute, get rid of the parenthesis signs. What's that convert to?
3a plus 3.
Minus what?
7 plus 3 halves.
A.
A.
Okay. Now, just like an equation, you want to get all your a's on one side, all your numbers on another. So how many total a's do we need to move to the left side of the equation?
4 1/2.
Which gives us what on the left side of the equation?
Negative a half.
And what's the numbers?
Negative 4.
Okay, now what do we do?
Divide by negative half.
Yeah, or I prefer to think of we're multiplying by negative 2. In other words, when we're trying to get rid of denominators, we multiply by the negative 2. So when I multiply the left side by negative 2, I get A. When I multiply the right side by negative 2, I get 8. Because I multiplied by a negative number, I turn that the other way. So A is less than or equal to 8. Do you understand everything we did there?
Yeah.
All right.
What about compound inequalities?
Bring it on.
3x minus 1 is less than or equal to 5, or 2x minus 4 is greater than or equal to x.
Okay, 2x minus 4 is greater than or equal to x?
Yeah.
Okay. I meant to write these horizontally. Let me just move this over. 3x minus 1 is less than or equal to 5. 3x minus 1 less than or equal to 5. Or 2x minus 4 is greater than or equal to x. Solve each one. Do it in 2 steps if you need to. To what?
X is less than or equal to 2, or x is greater than or equal to 4.
I think the right one is greater than, yes, excuse me, my mistake. Greater than or equal to 4. Okay, so to figure out what the solution is, let's graph both of those. There's 2. There's 4. We got x is less than or equal to 2, or x is greater than or equal to 4. So I'm not sure how your teacher wants the solution. That's one solution. If we're graphing it, this is a graph of that. Is this multiple choice by chance?
I have no idea.
No? Because I've been coming across some really interesting problems between the difference between or and. Do you have any and problems, or are all of yours or problems?
I have one and problem.
Let's do it.
Okay, it's negative 3x is less than or equal to 12, and negative 2x is greater than negative 6.
Just greater than?
Yeah.
Not greater than or equal to?
Just greater than.
Okay. So if we solve this one, what do we got?
X is greater than or equal to 4, and x is less than 3.
Okay, it's greater than or equal to negative 4. Don't forget that you have to divide 12 by negative 3. So you really have to do two things. You have to bring the negative in and turn it around. Okay, now since both of these have to be true, x is less than 3 and greater than 4, that's all real numbers. So no matter, hold on a moment, let me think for a second. Yeah, you're familiar with interval notation, aren't you?
No.
This sign here, when you have interval notation and you connect the intervals with that U, you're not familiar with that? That means or, whereas in logic connotation, that means and. And when you're doing and, you combine all elements of both sets. In other words, according to my graph right there, every x fits one or the other of these. Let me think about this for 2 seconds here. So, do you have answers on these?
No.
All right, I'm going with my first answer. I phoned a friend and they said go with that. So, all real numbers. You see why?
Yeah.
If it was or, then the answer would be x has to be either less than 3 or x has to be greater than minus 4. Since it's and, this is the answer right there. It's only x's between minus 4 and 3 that fit the and description. And means this, that means common elements of both sets. Gosh, you know, I'm not 100% sure. You've got another session. I'm going to look this up and give you a 100% answer. I had this understood 100% this afternoon with another student, and now I'm confused about it again. It's not often you do the and. I would say 95% of my students only work with ors. And ors are relatively simple. If you get an or, this is the way you write it. Well, in this case, you would actually write it like this. X is greater than or equal to minus 4, or x is less than, actually less than, not less than, equal to 3. So if it was an or, that would be your solution. But the and, I'm not sure. The more I think about it, it seems to me that the and should be just the overlapping part. But I can also see where the and is all numbers on the number line. All x.
I think it's just the ones in between.
Yeah, I think so too, because if minus 100, that wouldn't be true. If x was minus 100, both of them would not be true. The only time both of them are true is when it's between -4 and 3. I think you're right. I think it both have to be true for it to be and. Sure, that makes sense. That makes a lot of sense. Okay. Boy, I stepped in. I asked for that one. Yeah, if it was or, it would be all numbers on the number line. Because all numbers on the number line fit one of those inequalities. Only those 7 numbers fit both, which is and. Okay. What else you got?
It says solve an equation and check for extraneous solutions.
Okay.
The equation is an absolute value, 2x plus 3 equals 5.
Okay. The types of equations that give you extraneous solutions, just so you know, are equations that have radicals in them, equations that have absolute values in them, and equations that have logarithms in them. Those 3. A normal polynomial equation generally will not give you extraneous values. There you can construct some that do, but it's not common. However, this is fairly common, although I don't think this gives you an extraneous value. This is too straightforward. But how do I solve this? What does this mean? This means one of 2 things. It's a one or another. The first one is what?
2x plus 3 equals 5.
Or what?
Negative 2x.
No, never change what's inside the absolute value. Only change what's on the other side.
Negative 5?
Uh-huh. Makes it real easy to remember. No matter how complicated what's inside the absolute values are, don't mess with that. Just like this. So now solve each one.
Yeah, 2x equals 2, x equals 1, and
Or
2x equals 8, x equals 4.
I think it's x equal -4.
Minus 4.
Okay? And this one's definitely an or. When you have absolute value equations, that is an or. Okay? So that's the answer. And
Okay.
now we check it. Well, does 1 work? Yeah. 2 plus 3 is 5. Absolute value of 5 is 5. Does -4 work? Well, 2 times -4 is -8. Add 3 to it, you get -5. Absolute value of -5 is 5. So yes, both of them work. So that one doesn't have extraneous solutions. I'm sure you got one that does, though. We can just go through every one of them if you want until we get to one. Although I know you got a lot of material you want to cover, so I'll let you direct.
Yeah.
I'll let you direct.
This one's similar, but we have to graph it too. It's 5, absolute value of 3x minus 7.
Oh, hold on. It's 3x minus 7, okay?
Yeah, there's a 5 before that.
Like that?
Yeah.
Okay.
And plus 4 is greater than 29.
Okay. Let's talk about absolute values and inequalities. Let's talk about that right there. What does that mean? It means one thing or another. First thing it means is always if you just drop the absolute value signs. You get that.
Mm-hmm.
Okay? Or, never change what's inside, x, In this case, you have to change the direction and the sign. So understanding what I have circled here, what it means is important towards solving all of these harder ones. Okay? So, first thing we need to do is try to isolate our 3x minus 7 in the absolute value sign. So what can I do?
Distribute 5.
No. That's dangerous. How about we subtract 4 from both sides for the moment?
Mm-hmm.
Makes that 25. When I say it's dangerous, these aren't parentheses. So you don't really want to be multiplying scalars times that. You actually can do it, but it's not a good idea to do it. The best next step is to divide both sides by 5, because that isolates the 3x minus 7. Okay? Now, what does that mean? What two things does that mean?
Means 3x minus 7 is greater than 5, or 3x minus 7 is greater than negative 5.
No, change both the direction and the sign. Less than negative 5. And now solve each independently. And like I said, these are always OR problems, so you don't run into AND problems unless you got a teacher that gives them to you. So solve this one for me.
X is greater than 4.
And this one?
X is less than 2/3.
Good, you're getting quicker with your math. Okay, so what does that mean? That means that on a number line, if I want to graph that, there's 4. Here is 2/3. There's 0. So x is greater than 4 is open circle, that direction. X is less than 2/3 is open circle, that direction. And the answer would read x is greater than 4 or x is less than 2/3. Or you might reverse it so that it starts from left and goes to the right. In other words, this one first or this one.
Okay. Next, it's find the domain and range of each relation and determine whether it's a function.
Okay?
Be 2, -1, -4, 5, 1, 7, 2, -3, -1, 2.
That it?
Yeah.
All right. Let's plot these. Just for the first one. Second one is -4, 5. Third one is 1, 7. So far it's a function, right? In other words, if I can connect all the dots and it passes the vertical line test, it's a function. If it doesn't pass the vertical line test, it's a relation. 2, 3. Well, 2 is right here, and we already had a 2, -1. So 2, 3 is right there. They both have the same x coordinate and different y coordinates. The definition of a function is that for every value of x, you will have only one value of y. In other words, if I go ahead and plot the fourth point here, minus 1, comma 2, that doesn't violate anything. But if I try connecting these dots, I have a vertical line right here. That does not pass the vertical line test. You can't have a vertical line in a function. So that is a relation. Now, without having to graph every point, what are we looking for to violate a function is same x's, different y's. So when we find that, we don't have a function. We can have same y's, different x's. In other words, if I have this, notice that same y, different x at those 2 points. And yet that is still a function. It passes the vertical line test. So I can have, to be a function, I can have same y's, different x's, but with a relationship, same x, different y's. Relations are not functions by this definition. So no matter what table of numbers you want to give me, or coordinates, we can merely apply this definition to determine whether it's a function or a relation. You got more like this?
No, just that one.
Okay. It can be tricky to get those backwards. I mean, it's easy to make that mistake. The best, safest way to do it, if you have the time, is to plot out the points and see if it passes the vertical line test when you connect them. What else?
Suppose f of x equals 3x minus 4, and the g of x equals absolute value x plus 3. Find each value. First one's for f of 2.
Okay, what's that equal to?
2.
Okay. What next? In other words, whatever's in the parentheses, we plug in for x.
Okay.
So what's g of minus 3?
I thought it was g of 2.
Oh, I heard f of 2, and then I didn't hear the g of 2.
It doesn't give you one.
So it merely wanted to know what f of 2 was? Or it wants to know g of 2 also?
Well, it just says suppose f of x equals 3x minus 4 and g of x equals absolute value x plus 3, but it only gives me f of 2 to solve with.
Then f of 2 is equal to 2. I don't know why they gave you g of x. Is there another part to the question?
No, there's just no, there's another one, but that's the only part to that one.
Okay. That question doesn't make a whole lot of sense. There's all kinds of things they might want to know, They might want to know f of g of x, composite function. They might want to know g of f of x, another composite function. They might want to know f of x divided by g of x, or f of x times g of x. But to just ask about f of 2, we just plug in 2 to the f of x function only. And the g of x function doesn't have anything to do with it. If they would have said also, what is g of 2? What is g of 2?
G of 2 would be 5.
Okay. What is f of x minus 1?
F of x minus...
Remember what I said? Whatever's in the parentheses, plug in for x.
Would we plug in x minus 1 again? Or just -1?
No, exactly. Whatever's in the parentheses, you plug in for x. So that would be f of x minus 1.
Okay.
Okay? So no matter how complex, whether it's a number or another function or a complex function, that's what you do every time, is just plug it in for x.
Okay. The other one it gives me is it's f of 1/3 plus g negative 2.
Okay.
And we use the same f of x equals 3x minus 4 and g of x equals absolute value x plus 3.
Okay. So what's f of 1/3?
Wait. Do we just use the 1/3, or since it's plus g negative 2,
No,
plug that in too?
No, one at a time. Plug in the 1/3 to the f of x function. What do we get?
3 1/3 minus 4 -3.
And then we're going to add to that whatever g of minus 2 is. What is g of minus 2?
1.
There's your answer. Very straightforward. Okay?
Okay.
Confusion there at all?
No.
Okay. If there is, let's do another one. Well, something similar.
No, that was all I had.
Okay.
It says, this one I don't even know. It just says find the constant of variation for each direct variation, then find the value of y when x equals 3/4.
Okay, so there's the direct general formula. There's the inverse general formula. Okay, so what's the first one they're giving you? A direct one, right? Okay, so what do they say?
Y equals 2 when x equals 6.
Y equals 2 when x equals 6. So the way these are always solved is the first thing you solve for is k. This is the general formula. As soon as we solve for k, we will have a specific formula. So to solve for k, substitute for y and x.
Where does the k come from?
We're just calculating it right now. In other words, once we substitute for y and x based on those, we'll be able to solve for k. There's 3 variables. If they give us 2 of them, we can solve for the third one. So I've solved for k. Now I can write my specific equation for this particular relationship. That's it. So now if they say, okay, what is y when x is 30? You can answer it. What do they ask?
What is y when x is 3/4?
Okay. What is y when x is 3/4?
3/12.
Which is 1/4, yes. So that's how you do all of these direct relationships and inverse relationships and joint relationships. Is you set up the general formula, you solve for k. Once you've solved for k, you have the specific formula. And joint merely means if y is directly, or rather jointly related to x and z, it would be like that. Y equals k times x times z. If y is directly related to x and z and inversely related to the square of r, that's the general formula. In other words, you don't have to be directly or inversely related to a linear polynomial. It can be a squared polynomial, or a square root, or a cube root. Either way, if they gave you this problem, they're going to give you a y, an x, a z, and an r, let you calculate k, then you'll have the specific equation. Okay, we got about 15 minutes more tonight. What else you want to go over tonight?
Completing the square.
Okay.
Negative x squared minus 8x plus 5 equals 0.
When we're completing the square to solve a quadratic, in other words, there's a couple of ways to solve that quadratic. We could try to factor it. We could put it into the quadratic formula. Both of those would solve it. But there's another way to solve it, and that's by completing the square. When you're completing the square to solve it, what we generally do with this number is put it on the other side. So it's not the normal thing you do when you're solving a quadratic. You usually leave it on the same side. But I'm guessing that this definitely does not factor nicely. So we'd have 2 choices. We can either plug it into the quadratic formula, or we can complete the square to solve it. Either one will give you the same answer. Okay, completing the square. First of all, it requires something, and that is that the coefficient of the x squared term be 1. So how can I change this side of the equation to get that coefficient to be 1?
Divide by negative 1?
Yeah, exactly. Now, we're going to complete the square. So far I haven't changed it. Everything's exactly the same. How do I complete the square inside the parentheses? Which I can now do because the coefficient of x squared is 1. Do you know how? Take half of this coefficient and square it and add it right here. I've just completed the square. However, you can't arbitrarily just stick in numbers in equations. If I want to write in a 16 there, I got to balance it out on the other side of the equation, right? To keep all things equal. Well, what did I actually add to the left side of the equation? Did I add 16?
Negative 16.
I added a negative 16, which means I have to add a negative 16 to the right side of the equation to keep things equal. Now, this is still the same as this. I've basically done nothing other than added and subtracted a few things and divided out some stuff. The beauty is that now I'm able to write that as a binomial squared. So I have minus 1, and this always is whatever half of that middle coefficient was. Minus 5 and minus 16 is minus 21. Now what?
Distribute negative 1.
No. Again, we want to try to isolate this so that the next to final step would be take the square root of both sides. So to isolate that, I got to get rid of that negative 1. I can divide both sides by negative 1. That leaves on the left x plus 4 squared. On the right, 21. Now what? How do you solve an equation when one side is being squared? Take the square root of both sides. Okay? When I take the square root of the left side, I'm left with x plus 4. When I take the square root of 21, this is very important. Always remember that plus or minus square root of 21. 90% of my students forget that. And you will lose points on your test if you forget that plus or minus. It's plus or minus whenever you take the square root of both sides in an equation. Make sure that the side that has the number on it has that plus or minus. I can't repeat it often enough. Okay, what's the final step?
Subtract 4.
And I'm going to put it in front. Why? Because that is exactly the way the answer would look if you'd have plugged it into the quadratic formula. Minus b plus or minus the square root of b squared, so forth and so on. But it always has the number here, has the plus or minus there, and has the irrational number there. Same exact answer as we would have gotten if we would have used the quadratic formula to solve this. We would have gotten minus 4 plus or minus root 21. And in fact, the quadratic formula came from completing the square of the quadratic in standard format. It's actually pretty interesting. I was watching poker one night, and one of the guys had a PhD in mathematics, and they said, "So what's the quadratic formula?" And he says, "Well, I don't know, but I know how to find it by completing the square of this." If you do exactly what we just did to complete the square, in other words, you put that c on the other side, you factor out the a, you take half of this coefficient, square it, you end up with So know that if you ever forget the quadratic formula, you can start with the standard format of the quadratic and complete the square on it. Okay, what else?
I got one more of those.
Okay.
9x squared minus 18x plus, or minus 1.
Okay, I'm going to put that minus 1 on the other side like that, just to save time. Okay, now what's the first thing we have to do on the left in order to complete the square?
Pull out 9.
Leaving
X squared minus 18x.
No, you got to divide 9 from both terms. In other words, you have to make sure that after you've pulled it out, you got the same thing you started with. Notice that if I distribute this 9, I get 9x squared minus 18x. So always make sure you're not changing anything when you do each of these steps. Okay, now this is always plus. What number do I need to write in there?
1.
What have I just added to the left side?
9.
I'm going to add 9 to the right side. Now I got the same thing. Now I can write this in parentheses always as x minus whatever half of that was, quantity squared, equals 10. Now what's the next step?
Divide by 9.
So we have x minus 1 quantity squared equals 10/9. Now the next step?
Square root
Of both sides. What's over here?
b x minus 1.
That's on the left side. What's on the right side?
Plus or minus square root of 10/9.
Which is the square root of 10 over the square root of 9, which is plus or minus square root of 10 over 3. Whoops, I forgot to bring the 1 over. So that's not our complete answer. Got to add 1 to both sides in order to get just x over here. So it's 1 plus or minus the square root of 10 over 3. Again, it looks just like something that you would have gotten by plugging it into the quadratic formula. I don't know which is easier. Depends on the function. If the function is nothing but whole numbers, I actually find completing the square to be a little easier than plugging into the quadratic formula. Although, I don't know. That might be an exaggeration. Once you get good at it, once you get used to completing the square, it's just as easy. You got to do a lot of completing the square when you get into conic sections. I don't know if you, yeah, you were into conic sections for a while, weren't you? Parabolas, foci? Yeah. You didn't get into ellipses and hyperbolas yet? Okay. When you do, there's a lot of completing the square involved there. Anytime you're trying to get something into a format like this, it's useful to complete the square. Got 3 minutes. Time for a short one. What do you got?
Writing an equation in vertex form.
Okay. What is
y equal.
Go ahead.
This y equals x squared plus 4x minus 7.
Okay? Vertex formed where H and K are your vertex. So we want to put this equation so that it looks like this. Well, this is a little different in that we're going to keep everything on one side of the equation. I'm just going to move that 7 over a little bit. Little different than the way we did the last one. The last one we moved the number to the other side of the equation. Why are we keeping it on the same side of the equation? Because that says plus k. We know that when we're done we're going to need a number over here, not on the other side of the equation. So where we have to complete the square is this part here. So the only difference is that when we complete the square, we balance it out by doing the opposite to the same side of the equation. So what do I have to add here?
4.
Which means I got to subtract 4 on the same side of the equation. The last time we completed the square, when I added a number to the left side of the equation, I added the same amount to the right side. This is, everything's being done on one side of the equation, so I have to do opposite to balance it. Okay, now this can be stated how?
Y equals x minus 2 squared.
X plus 2. Because that term is plus. So it's always going to be whatever the sign is of that middle term. Minus 11. Now that's in vertex format. What's the vertex?
2, negative 11.
Minus 2, negative 11. Notice that our standard general form, it's x minus h. And h is the vertex. So had I had x minus 2, h would have been a positive 2. But since I had x plus 2, h has to be negative 2. You see why? X minus a minus 2 would give you x plus 2. It's an important point. You get it?
Yeah.
And then it's plus k, so k must therefore be minus 11. It's a little confusing because it's minus h and plus k. So what you have to make sure you figure out is what is h? Well, h must be minus 2 because x minus a minus 2 would result in x plus 2. So h therefore has to be minus 2. All right. Well, feels like we got a lot covered tonight, and it feels like you have a real good grasp of it. Better tonight than any night I can remember. Does it feel like that to you?
Yeah, for most of it.
Good. Well, we got, what, another hour to cover before your final?
Yeah.
And that is when? Let me just pull it up here and double check with you. Ah, what a day. I tell you what a yesterday, today, and Monday through Wednesday are going to be. Let's see. I've got you Tuesday at 8 for another hour.
Okay.
I will talk to you then.
Okay.
All right? All right. Bye-bye.
Bye.